In this video for Math 94, we will be discussing problems from section 10.3 and 10.4 in the book. These problems cover rational exponents and radicals. If you're working on the homework, this is like homework number 9, problems 1, 2, 7, 8, 9, 10, 13, and 14. You might recall, we've talked a lot about exponents lately. X to the n used to just be defined as x times x times x times however many you had, as long as you had n factors. For example, x to the fourth is x times x times x times x, so that you have 4 x's or 4 factors. But in the last chapter, you saw that we defined x to the 0 equals 1. We had an explanation of why that had to be true. And x to the minus 1 we defined as 1 over x. And again, we had an explanation why that had to be true. We also came up with the idea that x to the minus n is 1 over x to the n. We also talked a lot about these laws of exponents. You might look at these and remember them from section 10.1 and 2. X to the a times x to the b equals x to the a plus b. X to the a over x to the b is x to the a minus b. X to the a all to the b power is x to the a times b. X times y to the a is x to the a times y to the a. X divided by y to the a is x to the a over y to the a. And x over y to the minus a equals y over x, to the a power. Now, how can we expand this idea of exponents to radicals? Well, let's take the square root of 2. Now, what does the square root of 2 mean? The square root of 2 is that unique number that when multiplied by itself equals 2. So, the square root of 2 times the square root of 2 has got to equal 2. That means 2 to whatever power this is, let's call it n, times 2 to the n has to equal 2 to the first. Well, it's not too hard to see that since these bases are the same, we could use that law of exponents, that I keep the base the same and I add the exponents. That gives you 2 to the 2 times n equals 2 to the first, or n has to equal 1/2. Do you see that these two numbers have to be the same and they have to add up to 1? That definitely means this number had better be 1/2. So you can say the square root of x is equal to x to 1/2. But let's not stop there. Let's talk about the cube root of x. The cube root of 2 is that number that when multiplied by itself and multiplied by itself again is equal to 2. So the cube root of 2 times the cube root of 2 times the cube root of 2 is got to equal to 2. So 2 to some power times 2 to some power times 2 to that same power has got to equal 2 to the first. It shouldn't be too hard to see that these three numbers, since they have to be the same, should be 1/3. So the cube root of x equals 1/3. But why stop with 2 and 3? Why not go to any root here? The nth root of x. The nth root of x is equal to x to the 1 over n. Of course, I need to add this statement that provided this expression is defined, and we'll get into that a little more later. But let's do a little practice with this right now. For example, we can write each rational expression as a root and write each root as an expression with a rational exponent. So here, just getting practice with this definition, x to the 1 over 6 is the 6th root of x. And the 9th root of x is x to the 1 over 9. And x to the 0.5, don't let that 0.5 confuse you. 0.5 written as a fraction is 1/2. So that's the square root of x. We can use this if we want to help us evaluate some numeric problems. However, you can do a lot of these without having to use any of these rules of exponents. But let's go ahead and do that. The cube root of 125, you might already know the answer is 5. But let's just think about it this way. 125 to the 1/3. What number to the 1/3, what number is 125 related to the third root? Well, that's 5 cubed. 5 cubed to the third root is equal to 5. 243, the fifth root of 243. Let's see if 243 is equal to the fifth root of something. Well, I'm going to take my calculator out, and I'm going to try that. 243 divided by 3 is 81. Divided by 3 is 27. Divided by 3 is 9. Divided by 3 is 3. So 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 is 243. So I can see that this is the fifth root of 3 to the fifth. So that answer has to be 3. What is the cube root of negative 27? The cube root of negative 27 is the cube root of negative 3 cubed, which has to be negative 3. And what about the fourth root of negative 81? Now, if we are not considering complex numbers, negative 81 is negative 1 times 3 to the fourth. But we don't have complex numbers here. I don't have anything that represents the fourth root of negative 1. So this is no real solution. Now, all of these problems I could do on my calculator using these rational exponents. There are special keys on your calculator for cube root and fifth root and fourth root. And I'll show you where those are. But you don't even really need them if you use these rational exponents. Let me show you how. Let's do the cube root of 125 two different ways. If you have a TI-84 or 83, you should be able to hit this key marked math. Do you see that math key right down there? If you hit that math key, you should get this menu. And if you look at this menu, you'll look at number 4. Number 4 down there is the cube root of x. And so I get the cube root of 125, and that, of course, is equal to 5. Now, by the same notion, I could take 125, since the cube root is the 1/3 power, and I could take 125 raised to the 1/3 power. Notice the 1/3 must be in parentheses. That will give me 5 also. This might be useful in the next problem. The next problem was the fifth root of 243. You'll notice there's no fifth root there, but there is this right here, this x square root. What does that mean? Well, I'm going to quit out of this second mode. I'm going to clear my screen, and if I want the fifth root, I'm going to start with 5. I'm going to hit math. I'm going to hit number 5 here, and I'm going to put 243. That gives me my answer. I could also have used my rational exponents, 243 raised to the 1/5, and that also gives me 3. Those answers are the same as what we got before. Let's try this one, the cube root of negative 27. Easy to see that's negative 3. And let's try this one, the fourth root, and I'm going to do it this way. I'm going to take parentheses, negative 81, and I'm going to raise that to the 1 divided by 4. Again, make sure that's in parentheses, and you will see you will get a non-real answer here. So while you can apply these rational exponents to numeric problems, one of the things that's interesting is to think about how you can extend this to non-numeric problems. For example, what does the fifth root of x squared mean? Well, the fifth root of x squared is x squared to the 1/5 power, all raised to the 1/5 like that. Now, if you remember your rule of exponents, that if you have x to the a raised to the b power, that means x to the a times b. you can write this as x to the 2 times 1/5. And of course, 2 times 1/5 is 2/5. Notice the 2 is on the inside and the 5 is on the outside. Now, there wasn't anything so special about this particular example. I could have done the 7th root of x to the 3rd, or the 15th root of x to the 11th, and I would end up with the exponent inside being in the numerator, the exponent outside being in the denominator. So we can generalize this way. The nth root of x to the m is x to the m over n, again, provided the expression is defined. As we saw in the previous example, sometimes the expression isn't defined. Now, everybody knows the cube root of 8 is 2, so this answer is -2. But just to show you, you can think about this as 8 to the 1/3. And 8 to the 1/3 is 2 to the 3rd to the 1/3. Now, that 3 times 1/3 gives me 1, and that gives me -2. By the same reasoning, this one, you might know that the cube root of -1,000 is -10, so the answer here should be the opposite of -10, or 10. But you could think about this, if you wanted, as the cube root of -10 cubed, and that would be minus -10 to the 3 over 3, which, if you do the arithmetic here, still ends up to be the number 10. That might be useful in this case. This one is 81 to the 2/4. You might say, hey, wait a minute, 2/4 can be reduced to 1/2. Well, 1/2 is just the square root, and what's the square root of 81? It's 9. How about 32 to the 2/5? 32 to the 2/5 is nothing more than the 5th root of 32 squared. Now, you think about this a minute. You might say, hey, that's the 5th root. 32 is 2 to the 5th squared. And if I write this out, watch this, 2 to the 5th squared to the 1/5. If I multiply these all together, 5 times 2 is 10. Divided by 5, I get 2 squared, which equals 4. It's kind of fun to do these problems without a calculator, but of course you can. Let's just look at that last one. So if I take 32 and I raise it to 2 divided by 5, I end up with 4, just like we talked about there. It isn't so important to solve these numeric problems using a particular method. They're just to illustrate some of these definitions we've been using. Now, let's talk about 49 to the 3/2. I could think about 49 to the 3/2 as 7 squared to the 3/2, which is 7 of 2 times 3/2, using that law of exponents, and that gives me 6/2, or 7 cubed, and 7 cubed equals 343. 9 to the 1.5. Now, don't be afraid of decimals. Decimal in this case can be written as the fraction 3/2, so that's 3 squared to the 3/2, or again, 3 squared to the 3/2 is 3 to the 2 times 3/2, which is 3 cubed, which is 27. And 0.36 to the 2.5. 2.5 is 2.5. 2.5 is 5/2. I can think about this. 0.36 is 0.6 squared. Okay, 0.6 squared is 0.36 to the 5/2, and that equals 0.6 to the 5th. If you use your calculator, 0.6 raised to the 5th is 0.07776. I hope you have found this video useful.